Hello, welcome to today's lesson. Today we are looking at angles under plane geometry 1. So what are angles? Let's look at the definition for angles. Angles are formed when two straight lines or rays meet at a point. These angles are represented by the symbol called angle brackets and are usually measured using degree. Now let's see how these angles are formed using a diagram. Let's consider two lines P and Q which meet at the point O. The space between the line OP and the line OQ is what referred to as angles. Let's represent this using theta. So therefore, the angle POQ is equal to theta. Let's also consider the parts of angles. We have two main parts. We have the arms, which are the two lines that join to form the angle, in our case OP and OQ. Then also the second part, which is called the vectors. Now this vectors is the common point where the two lines or rays meet to form the angle. In our diagram, we can locate this at the point O. Also, angles are measured using several instruments, but the most common one we use is the protractor. As students, we can find this protractor in our mathematical sets. Now, since angles are measured using several instruments, our first assignment for this lesson is to name at least 3 other instruments that is used for measuring angles and how they are used. Next, we are going to look at the various types of angles we have. The very first one is what we call the acute angle. These angles are always less than 90 degrees. An example, angle 45 degrees, angle 56 degrees, etc. So as you can see on the diagram, our theta is an acute because it's less than 90 degrees. These angles must always lie between 0 degrees and 90 degrees. The second type we are going to look at is what we call the right angle. Right angle. These angles are angles that are exactly 90 degrees. So the angle 90 degrees is also called right angle. So as you can see on the diagram, our angle MON is 90 degrees. Next up, the third type of angle we are going to look at is obtuse angle. These angles are always greater than 90 degrees but less than 180 degrees. So as you can see, again, our theta is always greater than 90 but is always less than 180. So the angle theta must always lie between 90 degrees and 180 degrees. Now the fourth type we will be looking at is what we call the straight line angle, or what people call angle on a straight line. These angles are always exactly 180 degrees. So as you can see in the diagram, angle COD, which is more like a semicircle, is 180 degrees. This angle we want to look at is the angle we call reflex angle. Now, these angles are always greater than 180 but less than 360. An example, we have 205 degrees, 315 degrees, etc. As you can see in the diagram, the reflex angle theta is always greater than 180 and less than 360. That is, it must lie between 180 degrees and 360 degrees. The next angle we want to look at is called adjacent angles. Now, adjacent angles are angles that have common side and a common vectors. So as you can see in the diagram, The angle alpha and beta are adjacent because they both have the same arm, which is OR, and they are all from the same vectors O. So therefore, alpha and beta are adjacent angle. Now, the next angle we also want to look at is complementary angles. Complementary angles. These angles are angles which sum up to 90 degrees. So as you can see, the angle alpha and beta, when you add those two angles and it gives you 90 degrees, then they are complementary angles. Next angle we want to also consider is what we call supplementary angles. Here, these angles, their sum is always up to 180 degrees. So as you can see in the diagram again, the angle alpha and beta, when you sum and you are able to get 180, then you can say that they are supplementary angles. The next angle we are going to look at is what we call vertically opposite angles. Now, these angles have common vectors and they are also formed by the same lines. Now, vertically opposite angles are always equal in measure. Now, how do you identify vertical opposite angles on a diagram? So let's consider our diagram in the video. You can see that the angle AOC and angle BOD are vertically opposite, therefore they are the same. The same way, angle AOD and then angle BOC are also vertically opposite, so they must also be the same. Next up, let's consider perpendicular lines. Now, these lines are normally lines that meet each other or that intersect each other at the angle 90 degrees or right angles. So as you can see, the angle AB and CD are perpendicular because they meet at right angle. Then also angle at a point. Now these angles are normally formed when different or multiple lines meet at a particular point. Importantly, the sum of these angles must always be what? 360. So you can see the angle ABCD, when you sum them, you should get 360. Thank you for watching today's lesson. Remember to subscribe and share the link with your friends. Bye bye.